Welcome back. In this tutorial, we're going to learn about bit depth. In my previous tutorial on digital audio, I mentioned that the quality of the recording depends upon the sample rate and the resolution. The sample rate we discussed in my previous tutorial. The resolution, or bit depth, is what we're going to talk about now. Resolution means how many numbers were used to define the position of the wave at a point in time. The more numbers, the higher the resolution, the more precise the digital version will be. The resolution is measured in terms of bits, called bit depth or bit resolution. In this tutorial, we're going to learn what this means, how it works, and how it affects your recording, and what the standards are for commercial audio input. A bit is a digital measurement unit. If more bits are used in digital recording, the recording is more accurate than if fewer bits are used. Early digital recording used 8 bits per sample. Commercial CDs use 16 bits per sample, which today is considered the minimum bit resolution for digital recording. Superior systems use 24 bits per sample, which results in less grainy recordings, particularly if your signal levels are low. 32-bit depth is also available in some digital audio software, but this makes your files really big and weighs down your system, so just make sure you have enough resources if you're going to work this way. For most musicians' purposes, recording in 24-bit and then exporting down to 16-bit for the final mastered output is standard. It's generally thought that due to the limitations of human hearing, 24-bit depth is sufficient for audio recording. Most commercial CD players don't play 24-bit files, but CDs do sound better when they're recorded in 24-bit and then exported down to 16-bit. All right, I'm going to get a little more technical so you can really understand how this works. The higher the bit depth, the more zeros and ones are used to represent the audio sample. Because the data string that stores the value of the sample is longer, it's going to be more detailed, more precise, less distorted. It's less distorted because there's less quantization error in the binary numbers approximation of the sound wave. Whereas the sample rate affects the high frequency response of the recording, bit depth affects the dynamic range, the noise, and the distortion. Most commonly used are 8-bit, 16-bit, 24, and 32-bit depths. Each bit gives about 6 decibels of dynamic range. 8-bit depth is commonly used on the internet to keep your file sizes small. The data string is 2 to the power of 8 characters, or 256 characters long. So that means it can measure one of 256 amplitude values. It also measures a dynamic range of 0, the loudest, to minus 48 decibels. 16-bit depth gives you significantly more amplitude values. 2 to the power of 16 is 65,536, so a lot more. As you can see, 16-bit depth offers much more precision than 8-bit. The dynamic range it measures is 0, the loudest, to minus 96 decibels. So your pianissimos can be very quiet and your fortissimos will be really loud. 24-bit depth, or 2 to the power of 24, gives us nearly 17 million different amplitude values and also a much greater dynamic range, from 0 to minus 144 dB. Because the file sizes are so much larger in 24-bit than 16-bit, you need to make sure you've got enough processor speed, RAM, and hard drive space to handle and store all this data. 32-bit, or 2 to the power of 32, offers more than 4 billion possible amplitude values and gives us a dynamic range of 192 decibels. This is very resource intensive. Generally, top-of-the-line pro audio equipment supports this resolution level, but as I mentioned earlier, it's generally thought that 24-bit is more than enough for music recording. At the start of your project, you choose the bit depth at which your software will record data and make calculations. Once you've recorded or processed files in a certain bit depth, you can't increase the bit depth later on. However, you can reduce it when exporting to a file. You set bit depth at the beginning of your project. This determines the precision with which all your computer's calculations are made. If your processing is dynamic, like increasing the volume or applying effects, then no intermediate project files are created. But if you do batch processing, which creates intermediate files, like freezing tracks or normalizing, they'll be created at the project bit depth, and you can't increase it later on. And this concludes our tutorial about bit depth. In our next lesson, we'll talk about digital clipping.